Hello everyone, welcome to our pre-calculus class. This is lesson 13, graphing functions from the library of functions. So these are the agenda. We'll try to graph square root of x, cube root of x, and the modulus of x, and the library of functions, which actually indicates some common function that is needed in many occasions that will be needed for our class and for pre-calculus and calculus as well eventually. So first one is square root of x. Let's try to graph it. Okay, let's try to graph it. How can we graph that function? If x equals to square root of x, for graphing any of the functions, our natural processes, usual processes, we think about some values. This fx actually means the y, so basically you can write here fx or y. All is both is fine. Okay, so fx. Now think about it. What can be the value of x? What value you can put? So we usually put always from the real number. If we put x equals to 0, our value will come here. If you put 0 here, the square root of 0 means 0. And if we put 1 here, our value will come 1. If we put 2 here, so it is root 2. Root 2 means 1.4. 1.41 actually. If we put 3, it is 1.7 something. Root 3. Root 3 equal to this. And if we put, we can continue putting it. Let's say if we put 9. If we put 9, then it will be square root of 9 equal to 3. Like this. Now if we put minus 1, then it is undefined. Because the square root of negative number is undefined. So we have undefined then. So we have undefined. If we put minus 2, same will happen. If you put minus 2, same will happen. Even if you put minus 0.1, still it will happen. That means in the negative side, it actually is telling us, this is telling us that in the negative side, there will be no graph of this function. So let's try to plot them now. First of all, when x equals to 0, our fx equals to also 0, so we have it here. Then for 1, it is also 1. Actually, in this graph, the point falls here. Then for 2, it is 1.4. So 1.4 is somewhat here. 1.7 is somewhat here. Then we skipped a couple of points, 4, 6. Then we thought, okay, 9 equals to what? 9 is here and the value is 3. 1, 2, 3. So the point is 3 here. If we graph it now, it will look like something like this. Yeah. We have to make it as curved as possible. Okay. And our points are here, the point that we plotted. Here, let's use another color. They will look good. So this is red. We need some other color. This is another point. This is another point from our calculation. Then this is another point from our calculation. So this is the square root of x graph, and we can see a couple of things from this graph. For example, is it what is the domain of this graph? So domain actually starts from 0, goes to the plus infinity. What is the range of this graph? Range is also y value. Y value is from 0 to plus infinity. This kind of thing. Where is this graph? Is it increasing? Is it decreasing? This kind of thing. And you can see this is actually increasing graph. If you come from left to right, then basically it is increasing. This kind of a lot of questions actually we can answer when we look at this. This is the graph, and this is the graph from the book. So as you can see, this is matching with our graphs also, and this is how they get the points. Okay, this is how they get the points. We could take 4 because 4 is square root of 4 equals to 2. But yeah, that's fine in this point. So what are the properties? First of all, let's look at the properties, because that is one important things to discuss. The domain and the range are the set of non-negative real numbers. That means 0 to infinity, 0 to infinity. Domain and range both non-negative means it will not go to the negative side. But in the non-negative word, 0 is included. So non-negative means only the negative numbers. That means from 0 to plus infinity is the non-negative number. The x-intercepts of the graph is 0, y-intercept also 0. Yes, we know that because they are 0, 0 here. The function is neither or even or odd. This function is not even or odd. Okay, because to be even function, it has to be y symmetric, and to be odd function it has to be x symmetric. So this is not possible. The function is increasing on the interval 0 to infinity. So as you can see, as I said, from 0 to infinity the graph is increasing, because you see you hit this point, then the next point is up, next point is up, next point is somewhere up. So it is going up. Although the amount of increase is very small, and it will eventually become very, very small based on the trend of the graph, we can say that, but it is still increasing, we can say that. The function has an minimum of absolute minimum of 0 at x equals to 0. So this is the lowest point of the graph, because after this point the graph will not go down. That is the absolute minimum, that's why. So we can actually decide about this, what is the lowest point of this graph. Okay. Next one is cube root function. The graph is drawn here. Let's discuss it. The cube root function. Okay, this is cube root of x. So in the cube root of x, we have this function in our calculator also. You put 0 here. When we put 0, answer will be 0. We put 1 here. Cube root of 1 equals to 1. Then you put 2 here. Then cube root of 2 equals to what? We do not know. That's why we will put the value from the calculator. I will put it here. Cube root of 3, cube root of 4. This way we will try to plot it. We will try to calculate it. Then only difference here is if you put negative in the cube root number, suppose cube root of minus 1, answer you will have minus 1. Here you will get the minus 1 since this is the odd number. If this is odd number, then negative number of that root is possible. Let's say cube root, 5th root, 7th root, then negative number root is possible. And similarly, if you write cube root of, let's say, cube root of minus 9, you will get some answer. If you write cube root of minus 27, you will get some answer. Cube root of minus 27 is 3. This is 3, minus 3. Cube root of plus 27, just for same patterns. Plus 27 is 3. These are some common value. Cube root of 8 equals to 2. Cube root of minus 8 equals to will be, I'm just showing, cube root of minus 8 equal to will be minus 2. Yeah, so you see this is the value 2 and minus 2, this value. When x equals to 8, answer is 2. Then the same way we just plot it and then draw the graph. Draw the wherever our points goes, we will just follow that path, and that path will take us here. And that path will take us here. These are the properties of this graph. Just like our square root function, our cube root function also poses some properties, and very important distinction here is in our cube root function we have negative side also, we have the graph, so the domain is all real number, range is also all real number, set of all real numbers. X and y intercepts both at 0, 0 is still. The graph is symmetric with respect to origin, so you can see this corner and this corner is similar, so it is odd function. The function is increasing in the interval minus infinity to plus infinity. So this increasing part, as I said, always we say you look from the left to right. So you hit this point, suppose, then you see this next point is above your previous point. All the points are above the previous successive points. So every successive points is in the next. Second point is always upper in terms of their position. Okay. And how do you know that which point is upper, which point is lower? You have to think about it in terms of the y-axis. Okay, suppose you have one point here, one point here and one point here. Which one is upper? You have to look at, okay, which one is upper in my y line. So this point is upper. Okay, this point is in some higher place. Suppose even if some point is negative, this is negative, this is also negative. So you have to look at this and this. So which point is higher? This point is higher here on the y line. This point, this point. Which point is higher? This point is higher. This point, this point. Which point is higher? This one. This way we can understand. The function does not have any local minima or any local maxima because it's a continuous graph and there is no some curve like this. If we have some curve like this or some stop is, suppose if the graph is stop here, then we can say, okay, this is the maximum value. This is the maximum here. But since this curve do not have that kind of turning, then we do not know actually about them. That's why they are saying this graph, this function do not have any local maximum, local minimum. Once again, to recap, how something will have local maximum and minima. First of all, there must be arrow sign. We have the arrow sign here, so it is fine. This is good. But the thing is, our graph has to sometimes go up, then at some point it has to come down to get maxima and to get minima. Okay, it has to come down. But the graph is continuously going up. That's why we do not have them. This graph is continuously going up. There is no turning anywhere on the graph. Like it's not going up, then at a point it should come down to get maximum minimum. Okay, this is why we do not have it here. This is the modulus function. This is the modulus function. The graph we have here. Let me quickly tell you what is going on here. So for the modulus function, this sign is called the modulus. If you write modulus of x, it looks like this. And when you put a modulus of x 1, then it becomes 1. When you put modulus of, let's say, 2, it becomes 2. Just simply the value. Now, only difference is if you put minus 1 within this modulus sign, then it becomes 1, plus 1. If you put minus 2, then it becomes modulus of plus 2 minus 2 means 2. Only positive value we take when it is modulus because modulus indicates the distance. Modulus means the distance. Do you know what this modulus means? This modulus means the distance. On the number line, on the x-axis, this is minus 1, this is minus 2. This is what? This is minus 2. So what is the distance from 0? What is the distance from 0 of this minus 2? 1, 2. Distance is plus 2. Distance is always positive. That's why it is plus 2. This modulus means the distance of that point from the origin. That's why it is always positive. So when you have all of them, just you plot it, then you you will get for the positive values, you will get this line because values are not changing. That's why 1 plus 1, 2. For x equals to 2, y equals to 3. For x equals to 3, y equals to also 3. This way. For x equals to minus 1, y equals to 1. Because the second value, you see, you put minus 2, answer gets plus 2. You put minus 1, answer becomes plus 1. That's why we have our function like this. Okay, so this is the modulus of x function. This is the properties of the modulus of x function. The domain is all real number from minus infinity to plus infinity, but the range is, interestingly here, range is only from the 0 to the plus infinity. That is the range. The x-intercept is 0, 0. Y-intercept is also 0, 0. Y-intercept also 0. Or 0, you can say just simply 0. The graph is symmetric with respect to y-axis. So this function and this function, so it is even. You can see this side and this side is same. So it is even function. The graph, now here you will see the graph is actually from this point, the graph is increasing this side, and from this point, and the graph is decreasing from the minus infinity to 0. Then from here it is started increasing. The function has an absolute minimum at 0. Yes, we can see the minimum point, the lowest point here in this graph, and that is at 0. We know it here for this graph. For this graph we know it. So there are a couple of more graphs. This is x square graph. This is x cube graph. Square root of x. This one we discussed. This one we discussed. So there are a couple of more graphs here. This is page number. This is the page number of different graphs. Please feel free to look at them. These are very important. And this is the modulus of x graph. This is 1 by x graph. Very important graph. All of them. You have to practice. You should practice it. This is fx equals to integer of x function. This is not, it looks like very scary, but it is not that difficult. This fx means y. Let me quickly discuss this. Let me discuss the important points about this graph. This is y means y equals to fx, same thing. So basically integer of x. Just for a moment think about it. Suppose y equal to x. What is the graph of y equals to x? Y equal to x graph is if x equals to 1, y equal to 1, if x equals to 2, y equals to 2, if whatever the value you will just get this line. And in the negative side also you'll get this line. Okay, in the negative side also you'll get this line. This is y equal to x graph. So what is the difference between this graph and this graph? The difference between is when y equal to 1, x equals to 1. When y equals to 2, x equals to 2. When y equal to 3, x equals to 3. In this graph, both. But one thing is extra here. You have the decimal point also here in this graph. Like when x equals to 1.5, y equals to also 1.5. Okay, here you have the decimal, but here no decimal, only integer value. X equal to 1, y equal to 1, x equal to 2, y equal to 2, x equals to 3, y equals to 3, x equals to 3.5. No, we cannot take it because we said that we will take only the integer. Integer means 0, 1, 2, 3, minus 1, minus 2, dot 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 this side and dot 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 this side. Do you understand? Decimal value we cannot take for the integer. Decimal value we cannot take for the integer. But in the real number, decimal value, square root of value, all of them we can take in the real number in this graph. So this is the only difference between this one and this graph and this graph. And all other graphs is pretty much actually the same process, same way it goes. Very important, by the way, once again, let me stress it. Very important. All these graphs are very important. There are total 9 graphs, I think. 3 here and more 6 here, total 9 graphs. Everyone should know all these 9 graphs. This is very important graphs, and you should, as we said, these are important graphs, so you should practice all these 9 graphs again and again, so that even at the first time if we say that okay, what is the function of this graph, so that you can just sketch it without looking at anything. Okay. And that's all for today's class. Thank you all. Thank you very much. And see you all in the class. Bye-bye.